Hey, Math 20-1. So this lesson is going to be on inequalities. But first, what I'd like you guys to do is just for a little bit of review, because we kind of took a break from this. I want you to be able to make a piecewise function again. So I'll let you guys go ahead and actually do that for me with this expression. So look back to your notes if you want to, and also be able to solve inequalities. So remember that you're going to have two different solutions here, right? You're going to have the situation where you've got 2x minus 5 is equal to 11 for A, but you'd also have the situation where it's negative 2x minus 5. So you should end up with two answers for A and B because there's both those possibilities. Okay, so moving on to inequalities. As a review from earlier years, this one says solve the graph and the solution. So for A, if we make a line, and it says x is greater than or equal to 3. So if I had a point here where I know that that's 3, well, greater than or equal to is on the bottom, right? So what we do is we actually make a point. Maybe I'll make that different color. So our line would be that point, and then everything above, right? So greater than or equal to 3. B is a little different because it's gonna, this one's saying, so if we had 0.5, x is less than 5. So the way we would handle that is instead of having a dot, a green dot, you'd have a circle kind of showing that it's not 5. It's everything less than 5, and then maybe have a squiggle on the line going that way showing it's everything less than 5. Okay, so now on to the new stuff. So examples of solving inequalities. This is with one variable. We're going to move on later where we'll have x and y, but for now we just have x. So with this inequality, I've kind of got the steps for you to solve this. So it says x squared plus x minus 12 is greater than 0. What I want to show you is what we actually, before we get started, I want to show you with the graph what this actually means. So, okay, so what's going on here? If you look at the ones we did before, right, this was just in one dimension. It was pretty straightforward. Now this is really just happening in two dimensions. And it's the same kind of idea, though, but it's saying that this function, x squared plus x minus 12, where is it greater than 0? Well, it's going to be greater than 0 here, all the way up, and it's going to be greater than 0 there. So we need to figure out, really, we need to figure out where our x-intercepts are, because that's going to tell us our regions that are going to be going up or that are going to be above 0, and the regions that are going to be below 0. So the way we're going to do that is you solve this function as if you were looking for where it is equal to 0, because we're looking for the x-intercepts. That's really it. Where it's equal to 0, those are called our critical numbers. They're just important numbers is really what critical numbers means. So let's do that first. So for A here, if we factor x squared plus x minus 12 is equal to 0, then that would factor out to be x, and that would be negative 3 and positive 4, the numbers you get. So that's going to be where x is equal to negative 4 and x is equal to positive 3. All right, so what that's really telling us is that this point here is going to be negative 4 on the x-axis, and this point here, this other critical number, is going to be positive 3. Okay, so for part B, we've pretty much done it. Part B is just saying identify the regions of inequality. So if we had a line, well, just straighter line than that probably, it's going to be negative 4 and positive 3. So those are our critical numbers. So we pretty much drew that up here though. So 3 says use the chart method. So what we're going to do is we're going to make a chart. I'll just pause it and do that here in a second. Okay, and in that chart, what we're going to do first, like on the left side here, is we're going to put our regions into here. And what I mean by that is our first region is going to be everything below -4. Our second region would be from -4 to +3. That's our next region. And then our last region is going to be everything above 3. So we're just going to write that down here. So the first region would be x is less than -4. The second region is the blue region here. Maybe yeah, let's keep it like that. Is going to be x is greater than -4 and x is less than 3. Any idea why I didn't put actually check that. What I should do is also say equal to for that center region. And the reason why I put it for the center region is because I'm looking for where it says solve this inequality, where this function is greater than, not greater than or equal to, just greater than. So this region, -4 and up, that's going to be less than -4. Hopefully that makes sense. Okay, so then our last region that we have is everything above 3. So it's going to be when x is greater than 3. Now, I'm going to skip these two middle parts of our chart for a second. I'm just going to go right to the end so we know where we're headed. What we want to figure out is where x plus x minus 12, where is this function positive? Where is it above the x-axis? So what we're after is just knowing when this function is positive. So it's going to be positive. Well, that comes to our next point here. Let's fill in this part of our chart. It's going to be x plus 4 and x minus 3. That's just after we factored this, right? But the reason why I wrote that is because we can quite easily see now that if we put any number less than -4, so if I popped a -5 in there, so it could have been -5, -6, anything less than -4, then what you end up getting is a negative number, and that's all we really care about. So it's going to be negative in that part. If I popped in -5 into that one, then I'm going to have -5 minus 3. Yeah, that's still negative. And the reason why that was helpful is because I know that a negative times a negative, this term or this factor times that factor, is going to give you a positive. So I know that this function is positive when x is less than 4, which just means it's above the x-axis when x is less than 4. Okay, if we did the same thing for any number between -4 and 3, like let's put 0 in there. It's an easy one. So if I pop 0 in place of those, so if I put a 0 in there and a 0 in there, then that's going to give me 0 plus 4 is 4, so that's positive. 0 minus 3, that's negative. So I've got a positive and a negative multiplied together. I know that that gives me a negative. Okay, last one, if I put in any number greater than 3, so let's put in 4. So 4 plus 4 is going to be positive because it's 8, so positive. 4 minus 3 is still positive. So then this is going to be positive. So we can see that this function is going to be positive when x is less than 4 and when x is greater than 3. So for D, says solutions, a notation in just in graphing. We already kind of graphed it there. So we'd say x squared plus x minus 12 is greater than 0 when x is, and then these are our solutions, right? That one and that one. So when x is less than -4 and when x is greater than 3. So those would be our solutions. There's lots of solutions. There's an infinite amount of solutions to these kinds of questions. Okay, so I'm going to let you guys go ahead and do number 2. So again, the only problem you might have in this one, there'll be some good review, is that the a value there is greater than 1. So you'll have to do the factor by grouping method. But it's the same concept, so use the chart method again. Number 3, just know here it says graphing method. So everything's really the same. It's actually simpler. I'll just show you how to do the graphing method on the first one. So if I told you the graphing method on that first question, if you go to your calculator, all we need to do is figure out what our x-intercepts are. So this is, you just graph the equation, figure out where the x-intercepts are, and you can see where it's above 0. It's above 0 here, it's above 0 here. So we just need to go menu, analyze graph, 0, go to the left, go to the right, so it's one of the zeros is 3. Analyze graph, 0, the other 0 is -4. So we know that it's going to be positive when it's less, when x is less than 4 or -4, and it's also going to be positive, so above the x-axis, when x is greater than 3. So that's the other way of graphing it. So yeah, I'm gonna end this video. Oh, let's go cancel. I'm gonna end this video here, and I'll pick up the next video for 2 variable inequalities. So I'll see you guys in class.